Okay, picking up where we left off in 4.1. I want to start with what radian measurements means. Okay, we're going to start there with the foundation today and then work our way through the rest of these skills. Okay, so let's go to the second page, and I want to start here today. Okay, radian measurement. Let's get to the definition, what this means. It's basically a different way to measure angles. Think about measuring things linearly. We can measure things in inches. We can measure things in feet, yards, miles, if it's in linear distance, all kinds of different ways. For angles, we only have two, okay? Degrees, which is the most common, and then radian measurement, which is actually based off of a circle setting to start. All right, so the measure of the central angle means an angle centered in a circle. So why don't you label this right here, theta, for an angle right there in between. So they're talking about this angle here. And it's a relationship between the radius of the circle. So the radius for the central angle will be from, if this is centered, I know it looks a little off, but let's assume this is centered. So R will be here. And the arc length, if you remember from geometry, is that curved distance, okay? So S would be this distance here. Okay, that's between these initial sides and terminal sides. All right, and here's the definition of the angle, radian measurement. Okay, radian measurement is this right here. Starring it because this is an important definition. Theta will be equal to simply S over R, arc length over radius. Okay, and so when we calculate this, you got to just remember too, theta is in radians, not degrees. So theta is in radians, not degrees. Okay, I'm leaving some space over here for some common angles here that we're going to get to in just a moment. All right, so make sure you have S over R. All right. And the beginning of all these conversions starts with one revolution. So let me show you this real quick. This is a part I don't want you to write down. Just watch, please, and then we'll add our common conversions from this demo right here. Okay? So this starts with one revolution. If I take this central angle, start here, my initial side's here, I rotate it all the way around, my terminal side lands at the same spot, right? If you were to draw that angle. All right, so remember the distance around, if I'm going to express this arc length now, the distance around a circle, in geometry, we have a term for that. It's called circumference, right? Perimeter around a circle is circumference. So the formula for that is 2 pi r. Okay? All right, but for one revolution under this setting, that is exactly what the arc length is. Okay? It's equal to the circumference. It's S. So if I replace that with S, I get this expression. Okay? All right. So, like I said, just watch this here. So using that definition of a radian measurement, I have theta equals S over R. Okay? So for one revolution, what's S? It's 2 pi R. It's the entire perimeter. So I'm going to substitute it in right here. Okay, so the arc length is 2 pi r over r. Look at the r's can be reduced out, and I'm left with 2 pi. There we go. There is the first revolution, the first conversion factor. One full revolution, we know that's 360 degrees. We've known that for a long time. But what is it in radians? It's equivalent to 2 pi radians. Okay, so that's where we're going to start with these common angles. Why don't you label this right here, common angles. All right, so 360 degrees is equal to 2 pi radians. All right, don't get too fancy with this. It's like saying, 1 yard equals 3 feet. They're equal, they're just different ways to measure them, okay? All right, so if I know 360 degrees is equal to 2 pi radians, I can come up with a lot of other common angles by just doing some simple math here. Let's just say I divide by 2 on each side of this. If I divide by 2 on each side of this equation, I get a straight angle, right? 180 degrees. What's that going to be equal to? Pi radians. So that's another common angle we should add to our list. 180 degrees is equal to pi radians. Okay. Let's divide by 2 again. I don't think I need to go to that separate sheet. If I divide this by 2, I get 90 degrees. Do the same to the other side. We get pi over 2 radians. Okay. I'm going to do a couple more here. If I divide this by 2 again, we get another common one. 45 degrees is equal to, and then you take half of a half, it's 4, right? 1/4. So pi over 4 radians. Okay, I'm not going to get too cute with the math right now and show you how to come up with these next two, but for now, I want you to just add these. These are other common angles. Just squeeze it in over here. 30 degrees is also a very common angle. That's pi over 6. And 60 degrees is another common angle. That's pi over 3. Okay. All right, but that's kind of where it started. I started with 1 revolution. Since we know 1 revolution is 2 pi r, we could kind of come up with a method to do that. You don't have to recreate this scenario. This was just something I wanted to show you to introduce these common angles. Okay. All right, so now how do we come up with 1? Like you might have some crazy angle. What if it's like 185 degrees or 300 degrees? How do we convert it into radian measurement? Well, we need these conversion factors then. So basically what I can do, if I can go back to this scenario right here, if I want to know what 1 degree is equal to, I can divide both sides by 180. 180 here gives me 1 degree. Okay, so if I balance that and do 180 over here, it's pi over 180 radians. Okay, so that's what 1 degree is. It's equal to pi over 180 radians. Okay, so to convert degrees to radians, we multiply by pi over 180. Okay, put the degree symbol in there if you want. That's what we do. That's our conversion factor. Degrees to radians. Okay, and it's going to be the flip-flop of that, because if I go back and show you the same idea, if we want to figure out what 1 radian is equal to, and I erase this, what would I have to divide by? I divide by pi, because pi divided by pi is 1 radian, and then I balance it. So 180 over pi. All right, so to convert radians to degrees, we multiply by 180 over pi. Okay. Kind of gives you an idea how big a radian is too. How does it relate to degrees? So if I want to figure that out, since this is 1 radian now, I could just punch in 180 divided by pi. Oops, that's times pi, divided by, there we go. And 1 radian is about 57 degrees. Okay, so it's a big term, right? So let's put that over here as well. 1 radian is approximately 57.3 degrees. Okay, so let's go back to the other side now and fill in some of those angles. Parts we didn't do yesterday. All right, now I told you on the first day that just trust me, 9 degrees is pi over 2, but now I showed you why, right? We started with 360 equals 2 pi, and we broke it down and got some of these common angles. Okay, but now we should be able to sketch these angles in standard position in radian form now. Okay, a couple ways we could do this. You could use mixed numbers or mixed fractions to do this. Okay, or we can convert this. So let me show you what I mean by converting. Actually, let's go back to the other side one more time. I want to actually convert these first, then go back to the other side so we can use this skill. Sorry about that. I forgot I wanted to complete this. Okay, so 135 degrees. How do I convert that to radians? Okay, remember, if I have 1 degree is equal to this many radians. All right, here's the way you can make sure you set this up right too, because your conversion factor is either pi over 180 or the reciprocal. You want to make sure degrees cancel out. It's the best way to set this up. So put that over 1. And here's why I know to put 180 on the bottom. I want degrees to cancel. Okay? It's a foolproof way to make sure you have this set up right. And now just follow your rules of multiplying fractions. So I have 135 pi up top when I multiply across and 1 times 180 on the bottom. Okay, you will be expected to reduce these. If you're good at mental math, 45 goes into both, and you might know it's 3/4 right now. If not, you just do 135 divided by 180, math, change it back to a fraction, and we'll get the reduced form right away, right? So this is 3/4, so we write this as 3 pi over 4, just like that. Okay, no symbol to put. There should be no degree symbol. It canceled out. You might want to add the word radians. That'd be okay. But if it has pi in it, it's kind of assumed it is radians, so you don't really need to write it. Okay? All right. You could also write this as 3/4 pi, but the problem is some students, if they do that, they'll sneak the pi down here, and then all of a sudden it looks like 3 over 4 pi, which it's not. So it's best to just put pi in the numerator. Okay? All right, so try, once you pause the video at home and try to convert 14 and 15, and then I'll give you some feedback on that. All right, here's your feedback on 14 and 15. I mean, if you want to save the time of writing, this step, it's fine. Maybe you wrote down 330 pi over 180, or you just know to reduce this fraction in your calculator. It's 11/6. So 11 pi over 6 radians. A lot of times you just use RAD for short if you write that. But like I said, if there's pi in it, you usually assume it's radians, and you can just write it like that. Okay? All right, next one. Maybe you have the step in between, maybe you don't, but this reduces to negative 5 pi over 2 radians. Okay, so if it's a negative angle in degrees, it's going to be negative angle in radians as well. It's going to go the same direction. All right, let's go ahead and convert these now into degrees. So I have pi over 3 radians. I have to transform that into degrees. Okay, so it's going to be the reciprocal of this now, but if you kind of forget, what do? We want the pi to cancel out. Okay, so to make the pi cancel out, pi needs to go down here, and then these will divide out. So the 180 degrees is left up top. So multiply straight across. The pi is gone now, so up top I only have 1 times 180. So I have 180 degrees on top. On the bottom I have 3 times 1. So 180 degrees divided by 3 is 60 degrees. It's one of those common angles, or maybe you recognize it. Eventually, we'll be going through these so much you'll have some of these just memorized, and it speeds it up. Okay? Okay, your turn. Try 17 and 18. All right, here's the results for 17 and 18. Pi's on the bottom, cancels out. Even the word radians, right? If I put pi radians down here, they'll cancel out. We shouldn't say radians in the answer. We should have degree symbol. So 7 times 180 is 1260. 4 times 1, divide it, we get 315. Negative 630 for the last one.